Section 5.1 is rational numbers. I can write fractions as decimals, and I can write decimals as fractions. A rational number is a number that can be written as a quotient of two integers. Whole numbers and integers are both part of the set of rational numbers. In example 1, it says, show that the number is rational by writing it as a quotient of two integers. So, quotient of two integers, guys, just means we're going to write it as a fraction. So, rational numbers can be written as fractions. We can take whole numbers, like 7, and in order to write it as a fraction, we can make our denominator 1. We count up how many decimal places we have, and have that many zeros after the 1 in our denominator. Here I have no numbers after my decimal, so I don't need any zeros there. It's just 7 over 1. 7 divided by 1 is the same thing as 7. It works the same with a negative number, so negative 10. We want to write it as the quotient of two integers, which means we're going to divide, and my denominator is just 1. In C here, we have a mixed number. So, to get a mixed number into an improper fraction, because we just want it as the quotient of two integers, I take my denominator times my numerator, my denominator times my whole number, add my numerator. So here I'm going to take 5 times 4 plus 3, which is going to give me 23. And I write that over my denominator here is a 4, so I keep it a 4. 23 over 4 is the same as 5 and 3/4. Works the same way if it's negative. We just label it negative, and now we work with just the numbers. So 2 times 3 plus 1. Denominator times whole number plus numerator. Gives me 6 plus 1, which is 7. So right now I have negative 7. And that's still over my denominator here, which is a 2. So here we've switched both positive and negative whole numbers and mixed numbers into the quotient of two integers. If we take a rational number and divide it out, the quotient will either be a terminating decimal or a repeating decimal. If it's not, then it didn't start off as a rational number. In a terminating decimal, the division ends because eventually we finally obtain a remainder of 0. In a repeating decimal, a single digit or a block of digits in the quotient repeats forever and ever and ever without end. So some common ones are like 0.6 repeating. That's a repeating decimal. It's 0.6666666666666 forever. So here in example 2, we're going to write each fraction as a decimal. In A, we have 3 over 8, which means 3 divided by 8. So I take my numerator first, divided by my denominator. 8 doesn't go into 3, but it goes into 30. I'm going to bring that decimal point up. And since I'm using the entire 30 here, it goes in there 3 times. I put the 3 above the last digit there, that 0. Now I multiply it back. 8 times 3 is 24. Subtract, and we get 6. I'm going to bring down another 0. 8 goes into 60 7 times. When I multiply that back, I get 56. Now I subtract and get 4. Put another 0, bring it down. 8 goes into 40 5 times. When I multiply it back, I get 40. Subtract, remainder 0. So once our remainder is 0, my decimal has terminated. So 3/8 is the same as 0.375. In B, we have 5 divided by 11. So again here, 11 does not go into 5, but it does go into 50. So bring my decimal up. Goes into 50 4 times. We're going to multiply that back. Subtract. And here I get 6. Bring down a 0. 11 doesn't go into 6, but it does go into 60 5 times. Multiply it back. Subtract. 11 does not go into 5, but it does go into 50 4 times. Multiply. Subtract. 11 does not go into 6, but it does go into 60. And if you notice here, we've already done this same pattern. 55, subtract, we get 5. So originally we had 5, and then a 6, and then a 5, and then a 6, and now a 5. We're getting 0.4545. We'll get 4545 forever. So at this point, I'm going to go ahead and stop and say that it repeats. It's 0.45 because I have a 45 here and a 45 here, 0.45 repeating. And I need both digits there because both digits in that pattern repeat. Here we're going to write the fraction or mixed numbers as a decimal. So we're going to take 3 divided by 10. 10 does not go into 3. So I put my decimal, bring it up, and add a 0. 10 does go into 30 3 times. Now I multiply that back and get 30. We subtract, remainder 0. So we get 0.3. Because the remainder is 0, it has terminated. On B, I'm going to keep my negative sign as part of my answer. And then I'm just going to work with the 2 over 3. So I'm going to take 2, divide by 3. 3 does not go into 2. So I'm going to put my decimal here. Then bring it up. Add a 0. 3 goes into 20 6 times. When I multiply it back, I get 18. I subtract and get 2. 3 does not go into 2, so I'm going to bring a 0 down. 3 goes into 20, though, 6 times, which is 18. And again, I get that remainder of 2. I'm going to keep getting a remainder of 2 because this is a repeating decimal. So I take my 0.6, and since 6 is repeating, I put a repeating bar over it. So negative 0.6 repeating. In C, I have 1 as a whole number, so I'm going to keep a 1 in my answer, and my decimal goes after that. Now I can work with my fraction. So 9 divided by 20. 20 does not go into 9, so I'm going to put a decimal and add a 0. It means I need to bring my decimal up. When I'm comparing here, 20 goes into 90 4 times. 4 times 20 is 80. Remainder 10. 20 doesn't go into 10, so I add a 0 and bring it down. 20 goes into 100 5 times. Multiply it back. 100 with the remainder of 0. So 0.45 then, since my remainder is 0, is my decimal part here. So it's 1.45. And for D, I'm going to take 29 divided by 80. 80 does not go into 29. So I'm going to add a decimal, bring it up, and a 0. So 80 into 29, or 290 then, is you can think about it in terms of 8 into 29. So here, that's going to be a 3. Multiply it back. 80 times 3 is 240. We subtract, and we get 50. But 80 doesn't go into 50. So I'm going to go ahead and bring down a 0. 80 into 500, we can think about in terms of 8 into 50, which is 6. 80 times 6 is 480. We subtract and get 20. 80 does not go into 20, so I can add a 0, bring it down. 80 into 200, we can think about as 8 into 20, which goes 2 times, which is 160. When I multiply it back, we subtract here and get 40. 80 does not go into 40, but I can add a 0, bring it down. And 80 into 400, we can think about in terms of 8 into 40, which is 5. Multiply it back, 400, I subtract and get a remainder of 0. So finally we have a terminating decimal here. My final answer, 0.3625. Example 3 says, of the 50 mammal species found in Canyonlands National Park, 20 species belong to the order Rodentia. Of the 54 mammal species found in Badlands National Park, 24 belong to Rodentia. In which park is the fraction of mammal species belonging there greater? So the two parks, I have Canyonlands National Park and I have Badlands National Park. So we want the fraction of mammals that are in Rodentia. So in Canyonland, we have 20 out of a 50. So 20 out of a total of 50. And in Badlands, we have 24 out of 54. We want to know here which one is greater. So the first thing I'm going to do is I'm going to simplify my fractions here to make it a little bit easier to work with. So 20 and 50, greatest common factor is 10. So here I have 2 over 5. 24 and 54 have a greatest common factor of 6, which gives me 4 over 9. So as simplified fractions here, we can't necessarily tell. So we need to switch these to decimals. I'm going to take 2 divided by 5. 5 doesn't go into 2, but it does go into 20. Bring up my decimal 4 times. And when I multiply back, I have a remainder of 0. So here, this is 0.4. 4 divided by 9. 9 doesn't go into 4, but it does go into 40. Bring up that decimal 4 times, which is 36. Subtract, we get a 4. 9 doesn't go into 4, but if I add a 0 and drop it down into 40 4 times, which is 36, subtract, we get 4 again. So here, this is going to be a repeating decimal. It's going to be 0.4 repeating. So if we look, we want to know which one is greater. Well, when we compare these, I'm going to have 0.4 compared to 0.4 repeating. 0.4 means we have a 0 after, and 0.4 repeating means we have 4s after. So these are the same. 4 is greater, which means this is greater, so Badlands has a greater part that is in Rodentia. And I'll continue in another video.